If this capsule history of our progress teaches us anything, it is that man in his quest for knowledge and progress is determined and cannot be deterred. The exploration of space will go ahead, whether we join in it or not. And it is one of the great adventures of all time. And no nation which expects to be the leader of other nations can expect to stay behind in this race for space. Go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Okay, welcome back everyone to Reentry and Orbital Simulator. Last time we left off finishing the Mercury campaign, and now we are just doing the Gemini campaign. So we're in our new spacecraft, which we've tested, and we've tested the capability of modifying the orbit, which has been great so far. And now it is time for an EVA. Okay. Good day, Sonny. How's everything in Capsule 1? I bet you're excited to get up there again. Good day, yes indeed. The spaceship flies like a dream. I wonder when they will let you give it a try. Don't get cheeky on me, Sonny. I just heard the word. I'm scheduled for the next flight, a long duration flight. Sounds good, Patrick. Okay, we are ready here. Let's get this going. The backup crew has set up the capsule. Roger, let's do this. Complete pre-flight checklist and proceed when ready. Okay, let's actually get this thing going. So, good. All right, everything's looking good so far. All right. Raj, looking good. Let's just ensure. Fantastic. Ready to proceed. Mission control. Cockpit setup. Roger, go through the mission briefing and use timescale towards ignition. Roger, will do. All right, well, while we're here, let's just ensure that flipping switches isn't too loud. Flipping switches seems very loud, so when we do light the engines, we're going to be having a few problems. That should be good. Hopefully. Time scale very carefully. Everything's going good so far. T-minus 60 seconds. Verify platform alignment and the D-rings are installed. Okay, Titan, show us what you can do. T-minus 45 seconds. T-minus 40. 35. 30 seconds. T-minus 20 seconds. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Fire. Liftoff. Rolls in. Clock's starting. On our way to orbit. Roll complete. Rolls in. Pitch program. All right, everything's looking good so far. Right down the middle.
Mark, 50 seconds. You're looking good, 8.
Yep. One minute. Everything's looking good so far. We should be mode 2 now. Mode 2. Okay. Coming down. Oh, boost is not actually terribly loud, so I'll just kick that back up then. Okay, staging status. Level senses arm. And we are Roger. Go for staging. Values all show nominal here. Yep, we're good here. Go for staging. Staging.
Roger, staging.
Good. Curious how the handheld maneuvering unit and how it works while weightless. Well, we know it has 30 seconds of fuel, should be enough to see how it works, and if we can make it to the backpack, good thing that backpack has some additional fuel. The HHMU is used to translate forwards or backwards in the direction you look. Attitude is changed using normal attitude controls. Yeah, procedures are to turn off the ohms and venting the cabin before opening the hatch and exiting the craft. Yes, but first let's get this into the target orbit and complete the ascent checklist. Check the systems. Roger, preparing for insertion. Let's take a look. Values are looking really good here. I think we can clear out now. Okay, OAMS to orbit capability. Alright, level sense is armed. Prepare for cutoff. Engine shutdown. Roger. Sustainer engine cut off. Staging. Good stage separation. All right. Orbital insertion complete. Fuel system shut down. Waiting for scanner acquisition. Okay, we need to separate the spacecraft from the launch vehicle and remove the sensor covers. Already done. Zeroing IVIs. Roger. Press proceed when ready. Okay, performing the insertion checklist. Insertion checklist. Okay. So, insertion checklist is pretty nifty. Boost inserts and retro rocket squibs all off. We can stow the THC now that we're not maneuvering. Secondary O2 bottle closed. We need our ohms and water heaters on now. Yep, verify attitude control maneuvering electronics bias power primary. Roll jets are coupled to yaw. Attitude drivers primary. Suit fan 1 and 2. Primary pumps and secondary pumps A, both on. Bees are off. Antenna select adapter. Cryo quantity gauge off. Propellant quantity, I'm going to set to ohms so we can get a readout. Recorder off. Alrighty, and main batteries off. Squib batteries will remain on, apparently. AC power is on IGS. Right-hand bottle close. Fuels off, and computer to catch up. Waiting for the T plus 30-minute mark. Scanner acquisition. Roger. Tape is loaded. Let's get a temp check and go for flow. Checklist complete. Spacecraft configured for orbital operations. Roger. We will perform the EVA at mission elapsed time 60 minutes and the flight mode test now. We will start with rate command flight mode. Okay, let's turn the ohms on using ohms enable checklist and set control to rate command. We are already on rate command. Setting rate command. Spend 60 seconds getting familiar with how this mode functions, then move over to the direct mode. Roger. On rate command, when we hold, we go a certain amount of speed, and we keep going in that direction. When we let go, we stop drifting. Same with all axial directions. We are a little slow to stop moving, but otherwise, all is pretty good with the attitude control. Rate command is nice and easy to use. We spent 1 minute about, I would say. Let's go to direct mode. In this mode, you are fully responsible for all attitude forces yourself. Use small inputs and thrusts to change attitude for about 60 seconds. We are direct. So in this mode, when you hold down, you continuously increase rates, and when you let go, you continue moving. So this is unlike rate commands. When we go rate commands, the spacecraft automatically stops moving. Like so. In direct, the spacecraft does not automatically come to a stop. So you're responsible for all rates. Right now, we have the system set up so that these yellow needles do display our current rate of turn. So we are able to hold a very precise attitude using full manual control because we have our needles set to the platform and rate. It's good stuff. Maneuver to prograde attitude and maintain prograde attitude for about 2 minutes. That's quite a simple task. Just go platform, and on IGS platform, set SEF. And if you need to, we can also do small correction using the horizon scanner setting. This is very small minimum impulses, like direct. There we go. And we can also go into pulse and do the same thing, but with a much, much greater amount of pulsing. Back to rate command to stabilize, and back to platform for autopilot control. Okay, switch to SEF, take a small break. We'll start preparing for the EVA. We'll start at mission elapsed time, 60 minutes, just above Australia. Roger. So let's come forward then. I am slightly worried about having to do this at night, but I think we'll be okay. Okay, ready for the EVA? We are ready. I was just thinking about it. Will mission control... We'll let mission control know we are ready. Mission control, we are ready to start the procedures for the EVA. Roger. We just had a slight delay, but we are ready for you. Shut down the ohms and follow the EVA checklist. Okay, EVA checklist. Nice thing about this is that you are able to press the run, and it will highlight everything you need to do. We, of course, don't need this, but to show you how it works, I'll do it one time. So, Roger, preparing for EVA. The paper checklists are also more accurate as well. So keep that in mind. If you are using these runnable checklists, there may be slight inaccuracies compared to how it was actually done and how it is written on the checklist. For instance, we have retract for 1 minute, then off written here. But here, it just says retract and then immediately off. We know that is not true. We need to retract for 1 minute, then set off. Okay. Exterior lights to EVA, not to dock. Event timer set 0. Event timer is set 0. And start. Run the depress egress checklist. Okay, so record goes to continuous. Cabin air recirc is closed. Ohms control, power off, and vent the cabin. Okay, cabin vent is almost complete. There we go. Cabin vent is complete. Open the hatch. And yes, this is what the hatch looked like in real life. A little bit of a terrifying experience, a hatch of this design, to be honest, but... And let's go pulse and orbit rate. Good. Okay. Checklist complete. We're performing EVA. Okay, I've stepped out of the spacecraft. We'll give the HHMU a try. So if you have the C display, you have how much fuel you have left. First thing we want to do is back away from the spacecraft and not bump into it. So we'll give 2 very short pulses in the aft direction. Roger, be careful and spend as little fuel as possible. Try to get that backpack if you can, but that's optional. Make sure you return back into the capsule in time by using comms tools and menu and press enter. Roger, I'm drifting outside the capsule now. Use the HHMU to translate forwards and backwards in the direction you're facing. You can peek around using the right mouse. Roger, comms working great. Try to avoid hitting the spacecraft. Yes, that would be very bad. Or else I will start to get sick in here. Feels like a roller coaster? Most likely, I'll give you some space to give that backpack retrieval a try. Return inside when ready. We're going for the backpack. I'll stop here. And we are indeed going to go for that backpack. There is no way we're not. Okay. Give us a few puffs forward. And we'll start spinning around. Once we are to about here, stabilize. Get us a few puffs going in this direction. And come forward for the backpack. Okay, here we go. Targeting right where we want it. Approaching very smoothly. Okay, stop. We got the backpack. Look at that. Now, stop us from having a little accident here. Let's back up. How far out should we go? Not too far. I want to keep the spacecraft in sight, but we could go decently far, huh? Although I don't know what the time required for boarding is. I suppose that can happen at any time. We've got our TR-256 circuit breaker pulled, just in case we decide to go a little long on this mission. Sorry, mission control. But using less than 3 seconds of fuel to get that backpack, I have to say that's quite a new record. Let's get back inside. Come forward. And Tokyo drift towards the door, like so. Perfect. Takes a little getting used to. This HHMU is really a skilled craft. This thing here. Okay, slow our approach down and come towards the door. And hop right back in. Welcome back. You made it. Yes, we did. Sure, that was fun indeed. Indubitably. Mission Control, I'm back in the capsule now. I would say the HHMU worked well as long as I used it relative to my center of gravity. Roger, we are glad to hear that. Had a few blue faces down here. Can't wait to get a full report at the debriefing. Bring that capsule home. Roger, will do. Let's close the hatches, get this cockpit to orbital operations mode, and run the post-EVA checklist using the run feature. Right. Close the hatch. That light off. And let's get everything back to the way she was. Cabin vent is up. Closing the O2 bottle. Radiators in bypass. And repress. O2 consumption is nominal. Pressurization is looking good. It is a little hot in the cockpit, I must say. But we are on max cooling, so that's rather unfortunate, actually. Pressurization complete. Okay. Let's prepare for landing. Back to flow. Always forget that. We wish to splash down in the Atlantic, so our retrograde burn should be on the west coast of the United States. Again, using the orbital cursor, drag the slider so its position is above the west coast. Raj. Here we are, neatly above the west coast. Okay. Retro at orbital cursor, please. Sunny, time to retro has been updated to 1 hour, 27 minutes, and 8 seconds. Please double check core 19 and make adjustments if needed. No adjustments needed. We should now have a retrograde burn time. We will start the pre-retro checklist 30 minutes before ignition. Yep, and one of the things I want to do while we have the opportunity is get that set to 20. Time scale down to that 30-minute mark. I forgot to turn the outside lights off. There we go. Okay, T-minus 30 minutes from retro. Proceed with the pre-retro burn. Okay, or pre-retro checklist for the burn. Yes, here we go, pre-retro. Sequence lights are bright. Let's give a light test. All is okay. Close, time to retro, T56, or 256. FDIs. Attitude. Turn us around, blunt and forward, please. Left O2 bottle open. Close these two circuit breakers here, water and ohms. This light we will definitely need on. Okay, let's get the reentry C-band beacon on. Okay, and our TMs are going to be real time and acquire. Voltimeter battery test. All batteries are showing good. Okay, calibrator. And we could take the Gemini circuit breakers offline. Exterior lights off, engine stop, right hand bottle open. Eight, 7, 6, 5, 4, 3, 2, 1, start. Raj, okay. Reentry mode, loading into the computer now. And let's get our 256 checklists queued up. And I'm going to go grab a drink real quick. I will be right back. Okay, we're back. Okay, time skipping down. Computer program is still loading in a tape memory. $10. All right, tape loaded, computer on. Let's bring her down. Gently, we passed it. TR256. Okay. Computer's on reentry. Squid batteries are on. Main batteries are on. Oh, hello. That's a problem. Okay, well, that may be a small issue. That would explain why our lights are not working. Let's ignore it for now. RCS propellant, open. Gauge, RCSA. Record, continuous. Cryo selector off. Time to select reentry. Platform attitude. Scale is high. Platform attitude, scale high. Rate command, reentry. Gyros primary. Ohms control off. Acme. Okay. Indicate retro attitude. RCS on. Retro power on. Pilot FDI scale high. High frequency transmitter off. Coolant pumps off. Radiators in bypass. Starting 1 minute to retro checklist. One minute. Staging. Staging is confirmed. Okay, here we go. T-minus 30 seconds. Here we go. A little late on that, but we're good. Auto retro. 4, 3, 2, 1, Retro fire. Retro fire complete. Retro jet arm. Staging. Okay, staging's good. I forgot to run this. Yep, going through the checklist now. Checklist complete. Yep. Adapter separated. Yep, we got all that. Should have paid more attention to that, but post retrojet. Yes, let's do that. Computer, low. Boost insert. Yes. I'll keep those on for now. I hope we don't have to do this again. That would suck. Ohms control, propellant, circuit breaker. Fuel cell control. Tape recorder control. Switch positions to off on the fuel cells. Computer attitude, landing squib, arm. Starting entry checklist. Here we go. 170 degrees roll. Horizon at the top of window. Good. While we're waiting, I'm going to see if there's a way I can force advance this. I'll be back one moment. Okay, we got it. All right. We are getting ready for atmospheric entry. Good luck. Thank you. Okay. Let's get a mosey on. Okay. Waiting for the start of atmospheric interface. Let's just get a capture right here. Okay. And come all the way through. Okay. That's to make that nice dip to speed things up along here. Predicted splashdown is... Ooh, we may be over land. That would be rather unfortunate. Okay, we'll try and land long on this one then. Or we could possibly steer out of the way. Which may be what we do. Dig, 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 dig. Okay. All right, looking good. Yes, we've already finished having some G's. Yes. Oh, good. Capsule 1, do you read? Things are simmering down, following the landing checklists. This is Capsule 1, loud and clear. Do you read? Loud and clear. Yes. Not the best landing. We are quite far away from where we are supposed to be landing, but that's a-okay. Great to see you. We have visual. Welcome back. Roger. We got the drogue. Good, 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 good. Okay. Now just waiting for the regular shoot. Ah, that was pretty decent. How far are we in so far to the stream? We've been live for 1 hour, 1 minute. Okay. 1 hour per Gemini mission is ultimately not bad. All things considered, Gemini missions are pretty long compared to Mercury missions, I must say. So 10.6. Parachute open. Okay, we see them. Set the landing attitude and prepare for splashdown. Roger. Landing attitude set. Preparing for splashdown. In the meantime, attitude indicator control circuit breakers. Open and open. Rescue beacon without light. Attitude control and maneuvering electronics. Bias power off. RCS heaters. Where are those again? That's over here. I have that off and yep, off and off. Scanner heater off. Computer to pre-launch. Computer power off. That would mean manual data insertion unit power off. Platform power off. Rate gyros, yaw, pitch, and roll off. AC power off. RCS circuit breakers open. Acme control number 1 and 2. Open, open. We also don't need these or these. Or these. Can turn these off. And this. And that. Real-time, delay time transmitters. We'll still need that. Clock light. Yeah, we don't need that. We don't need the coolant pumps. Suit fans we need. Everything else we need. Okay. And splashdown. Complete post-landing checklist. Preparing for recovery, all in good shape. Welcome home and congratulations on another first. Why, thank you. What's the score again? I'll see you at the debrief. This is Mission Control signing out. Recovery will take over. End of mission. Next up, time for rendezvous. Rendezvous and docking with another spacecraft is another crucial task needed by the Apollo program, as astronauts will need to extract the lunar module from the launch vehicle as well as getting back from the lunar surface. The next mission was all about practicing these two methods. However, the target docking vehicle failed to launch. Patrick and his crew are still in orbit in the long duration mission, so we will try to rendezvous with them instead and leave the docking for another mission. The USSR achieved a rendezvous with the distance of several kilometers and had radio contact between the two Vostok crafts. However, no formation flying was possible. In this mission, you will rendezvous with another Gemini spacecraft and fly in formation with it using the OMS thrusters. Sounds like a plan. While we're loading, I'm just going to get a little bit more water. I'll be back. Good morning, Sonny. This is Capcom. This will most likely be one of the hardest missions yet. You guys all ready and set up? Good morning, Paul. Yes, we are all strapped in and the cockpit is almost ready for flight. Roger, just had a word with Commander Patrick. I think they're eager to see another face after a week in orbit. He also wanted to let me know that they completed 3 firsts, whatever that means. Roger, I can imagine they did. Let's get this spaceship up there. Sounds like a plan. Proceed with pre-flight checklist and report when ready. Okay, let's get everything set up. Okay, aligning the IMU for launch azimuth. Okay, we should be good to go. Sunny, verify platform alignment. We should be targeting an inclination of 28.91 degrees. Roger, we'll verify FDI program. Roll program to 0000. Verify that the cockpit is ready and prepare for launch. It looks like we have no motion. Computer and ascent. 72. And we're ready. Let's just verify all is complete. I get that to reentry real quick, because just in case we abort. But that should be everything we need. Self-check. Computer is start. Ah, yes, rate command. Forgot that. There we go. And we're good. Let's bring us down. T-minus 60 seconds. You know the drill. Here we go. T-minus 40 seconds. Fuel pumps. 30 seconds. T-minus 15, 14, 13, 12.
10, 9, 8, 7, 6, 5,
Fuel pressurizing.
3, 2, 1.
Ignition sequence. Fire. Bolts and liftoff. Rolls in. And clock is ticking.
Roger, roll.
Good liftoff.
Good lift all day.
It seems like we have lost battery 1. Really? Okay, let's see what you got there. Yes, Houston, we seem to have lost battery 1. Yep, I concur. Battery 1, we lost it. Capsule 1, we're seeing the same, digging into the data, but proceed for now. Focus on the ascent. Aaron, keep an eye on the electrical systems. Roger. Aaron, start checking over the other batteries and squibs. All good? They seem good. Let's keep them on during ascent and turn them off after insertion. We complete entry on 3 batteries. Roger. Proceeding ascent. Kein Problem. Prost. Ascent is looking absolutely spectacular so far. Right on the money with that pitch. Pitch program's looking good. And once staging is complete, we'll enter terminal guidance. Barometric altimeter is maxed out. Standing by for staging. I am curious, actually. Does this work? I'm not sure. There is not exactly a way to tell. Eh. Whoop, that scared me. Staging?
Roger, staging.
Okay. EPS looking good after separation. Pitching program's complete on terminal guidance. Three minutes, 30. Systems are looking good. Indeed they are. Yes, such a beautiful sight. Can't get tired of this. Yes, watch the panel. Wonder how Patrick and Matthew are doing. Yeah, they have to spend 2 weeks in this cramped little thing. It's absolutely terrible. Gemini has less space per person than the Mercury capsule did, and I noticed I'm peeking into the red slightly, so I'm just going to bump that down just slightly. You like to keep your voice in the yellow band and the game in the green band, and if you hit the red, it's too high. Yes, they're sure going to get a lot of time and space on their records. Yes, they are. That long duration mission made Jim Lovell the most traveled man in human history after Apollo 8. So, naturally, he was selected for Apollo 13. Curious on how it will be to fly in the Apollo program. Hope to get the chance to fly it. I'm sure you will. Yes, I'm sure there'll be a good chance for that after completing these missions. Amen to that. Let's see here. Everything is still looking good. We do confirm that we lost that primary battery, unfortunately. Yeah, we got Seco. Okay. Staging. Right. Let's zero the IVIs out real quick. Here we go. Perform the post-insertion checklist. We are working on the orbit circularization maneuver. Stand by. Roger. Let's hope the other batteries get back online for our retrograde burn and reentry. Yes, I sure hope they do. Okay.
Roger, DCS.
Okay. I hate when this happens. Okay, that's fine. Here's what we'll do. Let's focus on completing this first. Close. Required, yes. Close, close. Okay. Now then, well, we've got time to spare. Catch-up maneuver pad. 0, 0, 1, 1, 1. 0, 2, 4, 9, 7. And negative 0, 7, 3, 2. Negative 0, negative 0, burn time is 36 seconds. 36.58. Attitude is not applicable. And the predicted altitude will be 81.9. Okay. Is the catch-up computer module loaded? Catch-up module is loading. Okay, we are uplinking OBC update with the target parameters of the new circular orbit. The burn will take place at periapsis in about 1 hour, 5 minutes, 2 seconds. Roger, circularization burns scheduled for the next periapsis. Verify OBC cores and reference the circularization orbit checklist and bring this craft into a circular orbit. Use the map view. Yep. Raj. Let's bring us up to 30 minutes here. All right. Oh, that's a radio check. I meant to do radiator temp check. Radiator outlet temperature good. Set flow. Okay. And let's verify everything loaded in the computer properly. 111. 2497. Negative 731. Good. 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 Okay. All right, let's perform our circularization then. Engines armed. Standing by for ignition. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. That's supposed to be the other way. Yes. Adjust attitude here. Cut off. Okay, completely circular. All right. When ready, and the orbit is circular and aligned to 28.91 inclination, request target burn. Roger, DCS. Okay, catch-up burn is in. DCS uplink received. 4105. 4535. 1414. 0. 0. Perfect. 41 hours into the flight. Holy smolies. You guys, I don't even know if I'm going to have power that long. We have uplink to DCS with the burn parameters. Reference the rendezvous checklist as we work towards the burn and verify pad. We have uplinked before pressing start. Yeah, we're a little ways out from that. "41 hours, 5 minutes, 45 seconds." Okay. Christ, it's monitor H2. Well, looks like we might have it. We might just have the H2O supply. H2O supply. I mean H2 and O2 supply. We make H2O. We've got plenty of that. It's power consumption I'm worried about, but it looks like power has been rebalanced. So we're good on that. 20 hours. Five, 4, 3, 2, 1. All right, let's see here. Plenty of cryo. Good. 3 minutes to the burn. Burns 41 hours, 5 minutes, 45 seconds. Preparing for the burn. 1 minute. Precision is key. Good luck. Yeah. We'll need it. Okay. Radar on heat up. Nine, 8, 7, 6, 5, 4. Yeah, there's ignition. Here we go. Yeah, it looks like we got a nominal cutoff. Inch that just a little bit forward. Looking good. Setting radar to standby. Radar needs 5 minutes to warm up. Yeah, that's a little bit of a chaotic path here. That's a-okay. Radar is ready. Set it to on. This will automatically lock on Gemini when we are in range. We will arrive in 40 minutes and 19 seconds. Roger. Let's hope the burn will take us there. Preparing the next burn. Stand by. We've uplinked a new burn.
Roger, DCS.
Follow the circularization at Apogee checklist. Burn time, 41 hours, 50 minutes, 34 seconds. Acknowledge, DCS. Eight, good. 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 Okay. We're still coasting. Time to final burns, 36 minutes, 40 seconds. Everything's looking good so far. $41, $50, $34. 50 seconds. Computer start. Ignition. Cut off. All right. Setting computer to rendezvous. Change FDI source to radar attitude. Using radar to get close to the target. Starbird. Capsule 1. This is Starbird and Commander Patrick. Do you read? Loud and clear, Patrick. Loud and clear, my friend. Ignition. Cut off. Sounds good. Let's see how close we can get. Okay, throttle down there. Try to get within 300 meters of the target. There she is. Okay. How's that? We should be careful or we're going to smack into the thing. It sure is great to see you up here, Sonny. Did you imagine this would happen back in the academy? Definitely not. This is amazing. Hell yeah, it is. We sure could need a walk. Been here for 7 days already. Hope you're enjoying the mission, and the spacecraft sure is an amazing machine. Oh yes, this is a proper spacecraft. Compared to Mercury, yeah. Let's get closer and try to fly in formation. Certainly. Let's do that. Let's look face to face. Actually, no, I have a crazy idea. Computer is still not even loaded yet, and we've done this already, just based off of radar. The radar is just really powerful in here compared to Apollo's radar. Like, the Gemini radar is just crazy. Apollo radars, like, it's more crazy, but just the interface you use it with is a lot less intuitive. Makes things just a little difficult. But the station keeping is just really nice. Excellent work. Spend some time in proximity and try to get a feel of the craft and the impact on the thrusters. Roger, will do. Yeah, like I said, we're going to get more than just 100 meters. Let's park these puppies. Huh? This is awesome. Highlight of my career. You're right about that. I love the Gemini. It's very fun. Station keeping is just, it's like nothing you ever done before. It's super easy. And that is how you do that. Right. Okay. That's the end of this mission. It was pretty short. The press has gone wild after the first U.S. rendezvous information flying in space was achieved, including Commander Patrick's 14 days in space. A lot of work is still in front of us as we make progress towards the bold goal and dream of landing on the moon. A docking training module was just successfully launched into orbit at an altitude of 300 kilometers. It's your job to catch up with it, rendezvous, and dock. And this will probably be the last mission I play for the day. Maybe. Although it would be nice if I finished all the Gemini campaigns. That would be nice. Are we starting on the ground again? As much as I love rocket launches, there's not much I can comment about. We're starting on the ground. That's fine. That's fine. That's fine. Capsule 1, comm checked. How do you read? Yeah, we read you good. Let me just get everything set up for the launch after the panel state is finished loading. Loud and clear. Roger, the docking training target vehicle has been launched into orbit and will be slightly ahead of you. The mission will be similar to your previous flight with an addition of docking. Roger, we'll follow normal rendezvous procedures. We will ascend into an inclination of 28.91 degrees with the first objective of circulating the orbit before performing the rendezvous burn. Then we will approach the docking target and perform a docking. Prepare the cockpit for launch. Yes. Okay, prepare for launch. Okay. Actually, I should keep this on platform. It's looking really good. Okay. Garage. Okay. Internal power. And looks like we're ready for launch. Let's just verify. Good. All right. I'll wait for launch. Fuel pumps are in. 20 seconds to lift off. T-minus 15 seconds.
10, 9, 8,
Fuel pressurization.
6, 5, 4, 3, 2, 1.
Ignition. Sequence. And fire. Lift off. Good roll.
Roger roll. Good lift off, 8.
Pitch program started.
Roger, pitch program.
Ah, yes, I just remembered I may be interrupted in this live stream.
Mark, 50 seconds. You're looking good, 8.
But I will be back at some point. Okay, we are coming up on staging very shortly. Level sense is going to be armed in approximately 5 seconds. 4, 3, 2, 1. Mark. Level sense arm. Staging sequence is in. And it looks like we're go for staging. Roger, staging. Okay, we've got ohms to orbit capability, and we are level sense arm on the second stage, coming up on Seco.
Roger, Seco.
Seco, we'll separate from the launch vehicle. Staging, and there she goes. Okay, zero the IVIs. IVI zeroed. Completing insertion checklist. Roger, we'll go. Follow the circularization orbit checklist and enter the circular orbit at periapsis. To do this, yep. Sounds good. Let's do that insertion checklist. Right. Let us get ourselves circularized at our periapsis.
Roger, DCS.
One, 1, 1, 2, 4, 1. Negative 786. Negative 0 and 0. Good. Oop. She should be 9. Good. Take us up to 30 minutes. Good. Radiator temp. Good. And catch up. And sharp and forward. Got a lock. Everything's good. Gonna prepare for rendezvous. Burn begins at 1 hour, 11 minutes, 12 seconds. Okay, let's get time skipping. 1 hour. Whoop. Shit, we passed it. Yep. That's okay. We'll just get another one.
Roger, DCS.
Gotta be careful with those time skips. 239. 5. 8. Yeah. 26. And a 27. It's good. 27 is supposed to be that. Other than that, let's get to 2 hours, 39 minutes then. Two hours. $30. 1, 2, 3, 4, 5, 6, 7. Okay. Start the computer. Burn takes place 2 hours, 39 minutes, 15 seconds. Nine, 10, 11, 12, 13, 14, 15. Ignition. Cut off. All right, that's good enough. Request target burn when ready. Uplink.
Roger, DCS.
GETI at 14 hours, 48 minutes. 14 hours, 48 minutes. 36.8 seconds. 1464. 0 and 0. Looking all good here. Follow the rendezvous checklist and perform the rendezvous burn. Okay. Okay. So we've got the burn at 14 hours, 48 minutes. Let's get to there. Lots of waiting for these rendezvous, which is something we don't have to deal with on the moon. Those lunar batteries certainly don't have 14 hours. But when you do the Holman transfer in this inefficiency, Holman transfer is quite inefficient and slow, so... $14 hours coming up on 14 hours, 48 minutes. Okay. Langsam. Okay. Computer start. 48 and 36 seconds. Round that up to 37. 37. 36.8 is closer to 37. 48, 37. 48, 37. Ignition. Two, one, cut off. Let's just ensure that that is perfect. There we go. We're now coasting towards the target satellite if everything went well. Preparing the radar. Yes, radar to standby. Roger. Again, give it 5 minutes of warm-up time. Not a problem. Reset the computer in the meantime. Okay, radar is ready. And acquisition should automatically lock onto the target when in range. We should arrive in 39 minutes, 14 seconds. Request circularization at apogee.
Roger, DCS.
DCS uplink received. 15.33. 7.35. 1461. Good. 1533. 07. 1533. 07. Yep, I'm good enough with that. In the meantime, let's get the acquisition lights 0, 5, or 2, 5, 1. Let's get those repaired. 2, 5. There we go. Okay. $15.33. Turn on the encoder so we can use the radar to command the Agena. Roger. Encoder is on. It made me lose track. 15.33. Shush. When in range, send a command 251 to the encoder to automatically turn on the acquisition light of the target vehicle. 50 seconds burn. Align sharp end forward. 15.33. 07. 15. Yeah. Our burn happens a little later than your burn, all right? Stuff, just shut up. Stop talking. $33.07. Ignition. Set the computer to rendezvous. Start it when ready. While the OBC module is loading, change FDI1 source. Yep. Okay. Looks like she is right under us yet again. Yep, prepare for docking. Yes, yes. We'll get there. Docking checklist complete. Oh, what the hell? Man, it's just like in real life. Look at that. Hold on. Uh, 141. 2. 201. 250. Man, it is literally just as I thought. Look at that. Something's wrong. We'll move closer and verify. Roger, perform some formation flying around the target and verify the situation. Yes. Let's do that. It would appear to me that the bus is unable to be docked with. Seems the fairings are still attached. It's partially open, but it seems to be stuck by a wire or something. Yes, I agree. Roger, fairings are still on. It will be too dangerous to perform a docking at this time. And this is the shitty version of the Aegina too. Roger, what is the plan? Abort the objective and return home. Roger, returning home. Okay. So close. Yeah. I sure hope so. This is the third failed attempt at docking, and 2 of them were part of our objectives. Indeed, we'll get it next time. Yeah, this is the one that doesn't have the engine on it. Just like in real life. Would you look at that? Okay, well, I have a meeting coming up, so I think that that is where I am going to have to possibly take a break or end. I really would have liked to finish the Gemini campaign, but it is what it is. I will get another opportunity at some point, so stick around for that. It should be at some point in a few weeks, probably, unfortunately. So I apologize that I have to cut the Gemini campaign shortly, but I do have a meeting coming up. So alternatively, what I can do is I can take an hour break, keep the stream going, take an hour break, come back, finish the Gemini campaign, and possibly even start the Apollo campaign. What are your thought processes on that? Should I stop here? Wait for next time. I am in Urlaub. I'm on vacation, so it could be quite some time because I'm not home. Or do I keep the stream going? I can start the next mission, get into orbit, do everything as much as I can, right up until that 55 minutes mark, and pause there, have a short meeting, come back, finish the mission, and start Apollo. What do you guys think? The first Apollo mission takes an hour and 30 minutes to complete. It's all cold and dark startup. So if that's boring for you, I would take the first option. If that's not boring for you, then we can do that today. I myself am leaning towards option 2, so I think let's finish this. Multiple unsuccessful docking attempts have been made due to technical issues with either the docking target or the target vehicle carrying it. As you are getting very good at rendezvous, it has been decided that you will get back up there and complete the job. A larger target vehicle named Agena has been launched up there, and a reattempt at the first ever docking will be made. The Agena has a propulsion engine that will be used to get into record-breaking altitudes. Let's flippin' dock. The Agena target vehicle is launched into orbit. You will retry docking, and if successful, use the Agena engine to raise your orbit to 755 nautical miles in altitude before returning home. If successful, this will be the first docking in history, the longest distance humans have been from Earth. The Block 1 command module spacecraft is also rapidly making progress in the Apollo project, meaning we are slowly getting closer to the moon. Let's load. Okay. Welcome to the Gemini spacecraft. Seeing as this will be our last mission, I think I'll explain a few things. The Agena has successfully reached its circular orbit of about 160 nautical miles altitude at inclination 28.91. Roger, sounds good. Let's catch up with it. Prepare cockpit for launch. Complete the pre-flight checklist and align the platform for 28.91 degrees. Roger, pre-flight checklist and platform alignment. Report in when ready. Okay, so first things first, you're going to want some power. Switch AC to IGS immediately. Take TR-256 off. You need to switch this because one of the previous checklists has an amendment for that. The TR-256 circuit breaker prevents the reentry sequence or the retro sequence from starting when you're in your mission, so you don't have to keep reassigning core 19. And then take these two off because they're not required for launch. Flip this to primary, yaw, and primary. I always forget to do that with the attitude drivers. Alan, let's get some power. Main batteries and squib batteries on. You're going to start the fuel cells now. A1, and you're going to you should properly verify that all these have volts, but I usually just flip through really fast. It's all good. On and on. Now, computer power on and manual data insertion unit on, and the computer will begin its pre-flight or pre-startup tests. Take your boost insert squibs, your retro rocket squibs on, suit fan number 1 and 2, and the 2 glycol cooling pumps, and that's it. Temperatures and everything will adjust accordingly. The squibs are little explosive bolts that explode to stage the rocket and to do different actions. We'll be highly familiar with those by the Apollo program, because they have a lot. Next up, get your platform or your computer setting to pre-launch and start that program, which will align the ball, the guidance system, to the azimuth. You can get your attitude indicator lights on as well. And then at this point, the alignment stops going into course mode and runs into torque mode, pulse torque mode. And after pulse torque mode is complete, I usually wait a couple seconds. Once that's done, flip her into ascent, rate command, open your prop motor valves in case you need to abort, but do not start the control power. And then address 72 has some launch information that you can pull up while you're launching. And then I usually, for this one, make sure that I've done everything. You can see displays total velocity, yes. So you know when you reached your orbital capability. And that is everything for launch. Let's get this puppy into orbit. I'm ready. Telemetry indicates a healthy and operational Agena. Roger that. Hope to make the docking this time. We all do. 60 seconds to launch. 30 seconds. Fuel pumps are in. T-minus 15 seconds. 13, 12, 11.
10, 9, 8, 7, 6, 5,
Fuel pressurization.
3, 2, 1.
Fire. And liftoff. Yes, clock is ticking. And roll is complete. Good liftoff. Here comes the pitch program. Everything's going nominally. 50 seconds.
50
Good.
seconds, you're looking good, 8.
Looking good. Fuel and oxidizer pressures are good on stage 1. Okay. Mode 1, 2. Mode 2. Mark 140. Mark 1 plus 40 looking good. Mode 2. Go from the ground for staging. Roger. And level sense arm. Level sense arm. Stand by for staging. 5, 4, 3, 2, 1. Staging. Come on. There you go. And ignition.
Roger, staging.
Terminal guidance. Initiate. Fuel and oxidizer on stage 2 look good. Second stage is a real good machine. Cabin pressure is 5.5 and holding. 5.5. How that view gets me every time. That's fantastic. Okay, stage 2 is nearing halfway through its burn. Halfway. Here we go. Ohms to orbit capability. Ohms to orbit capability. And a level sense arm. Stage 2 is nearing depletion. Mode 3. Standing by for Seco. 3, 2, 1. Seco.
Roger, Seco.
We have Seco. All right. Spacecraft separation. Come on. All right, stage 2 separation and jettison the fairings. Raj. Stage 2 separation. Zeroing IVIs. Perform post-insertion checklist. We're working on orbit circularization maneuver. Stand by. Roger. Okay, I believe that's everything.
Roger, DCS.
Forgot that. Yep, there we go. Okay, in 30 minutes, request radiator temp check. Okay, Roger. DCS uplink, 1 hour, 11 minutes, 35 seconds. Delta V, 70.52 feet per second. Raj. DCS uplink, acknowledge. 111. 3502. 90705. 0. And 0. Okay, let's go to catch-up. It will need 10 minutes of loading. Catch-up module running. Okay, we are uplinking OBC update with the target parameters for the circularization burn at periapsis in about 1 hour, 4 minutes. Roger, circularization burn for the next periapsis passing in about 1 hour, 4 minutes. Prepare for the burn using the circularization orbit checklist. Okay. And that is where I'm going to need to stop for now, but we'll time skip down to that 30-minute mark and get that radiators to flow. There we go. Okay, I will see you all after my short meeting. Let's do this side. Nah, this side's better. All right. And then we'll do a little bit of that. And I'm thinking that is good. Okay. I will see you all when I'm back. Thanks for stopping by. Okay, welcome back. Welcome back. Finally returned, and I already forgot what time the circularization was taking place. 1 hour, 11 minutes, 35 seconds. Sounds good. Well, in that case, 1 hour, 11 minutes. Let's get things rolling. I'm anxious to start Apollo. 1 hour, 11 minutes, and 35 seconds. Computer start. 1, 2, 3, 4. Ignition. That's the wrong way. And there we go. Cut off. Orbit circularization complete. There we go. Request target burn. Let's do that. Roger DCS. We've got a GET of 34 hours, 22 minutes. That's quite some time. Following rendezvous checklist, getting on a rendezvous trajectory. We are, yeah, that is absolutely not correct there, Aaron. We are definitely not that amount of time from the rendezvous burn. Absolutely atrociously incorrect information. All right, let's make his information accurate, I suppose. One minute. Let's get it as precise as earlier. Yes, let's do so. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Mark. Pitch down. A little left. Yeah, a little left. Pitch a little up. Pitch a little up. 5, 4, 3. Pitch a little up. 2, 1. Cut off. How is it? Just kiss forward. There we go. That's perfect. Rendezvous radar to standby. Warming up the radar. We've got good amounts of fuel, good amounts of cryo. Everything's looking good so far. Roger. Radar lock on. Let's get ourselves a apoapsis circularization. Well, let's wait for them to tell me to do that. I imagine they'll tell me soon. Possibly not. Okay. Apoapsis circularization.
Roger, DCS.
DCS uplink received. Okay, GETI 03506-05028. 03506-05028. Delta X is 1406. Delta Y should be 0 or -0. Delta Z should be 0 or -0. Burn time 70.35 seconds. Okay. 350650.
Roger, DCS.
Okay, well, yeah, we did that. Uplinking the final rendezvous burn. Well, now I need to check it all over again. 3506 4892. Yep. 1407 0 0. Good. And that works with the checklist. Yep. Perfect. Execute the burn as normal by following circularization checklists. Already ahead of you on that one. So 3506. Let's time skip. Yeah, set the encoder on. Encoder is on. Let's get dock lights on and bus arm to dock. And extending the index. When in range, send the command. Yes. (17 minutes) 15, 14, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, 50 seconds. Sharp end forward. Computer start. Fuel valves open. Here we go. 48. 3, 2, 1. Ignition. A little bit pitch right, or pitch down, and you're all right. Three, two, one. Cut off. Okay. Computer's on catch up. And let's display the radar attitude. And let's dock with this thing. Yeah, we don't need the acquisition light on, but if you're curious to see what that looks like that. Looks pretty cool. Anyways, let's get moving towards it. We could turn that off and instead do 141 and 201. Let's do 201, 141. Okay, let's start moving forward. I already see the docking system. It's located right beneath us. Moving on for final approach. Beautiful. Tell you what, the station keeping is so easy. It's really like nothing you ever seen before. Turn on the docking lights and acquisition. Turn off the acquisition when ready. Yes, we've already done that. Let's align for docking. Okay. Really good. Align with the Gemini and perform the docking. Already ahead of you on that one, good sir. Alright, now the real question is the computer loaded? Nope. Okay, not a problem. We don't need to know our docking attitude. I got this. That's what a pair of trained eyes is good for, huh? Good set of trained eyes. Back her up a little bit. There we go. Just needs to be a little bit like that. Why don't you want to dock? Come on. We're in there. Why do you not want to dock? Hello. Okay. Alright, that's a weird glitch. But it worked out in the end. We have docking. Alright, cycling the rigid stop valve. TDA control, rigidize. We are rigid. We see Agena control. Good. Great job, and hello, Agena. Excellent job. Complete the post-docking checklist and take a break. This completes our primary objective. Congratulations with the first docking in history. Another well-deserved first for you. That puts me in the lead again, right? That is correct, Sonny. Score is now 7-6. We are moving out of range. See you in about 10 minutes. Okay, excellent job. We finally made it. Yeah, great job. Takes 2 to do the job. We will soon take a break and then fire up that Agena engine. Can't wait to see Earth from record-breaking altitudes. Exactly. Planned orbit is at an altitude of 755 nautical miles, the highest Earth orbit ever achieved by a crewed spacecraft. Verified OAMs is off, and set control mode to free. Okay, let's get that post-docking checklist. 140, exterior lights off, bus alarm safe. So 140. Okay. Oh, hello. Okay, it seems we are building some roll. Yes, is ohms closed and shut off? Ohms controller power is off, and the same with the ohms propellant valve. It can't be us. Okay, it seems we are having a thruster issue with the Agena. Roll building up, shut off the Agena control systems. Encoder 400. Okay, 400. Agena control system shutdown. Roger, 400 done. Roger, let's use ohms to reduce roll. Enable ohms setting control mode to direct. Control mode is direct. Okay. Oh. It must be with the Agena. Keep stabilizing. Roll as good as you can. Press the emergency release when ready. And back away when undocked. Roger. Okay, bus arm to explosives. Here goes. Okay, stabilize. Okay, stabilize. Ready? Release. Undocked. Capsule 1, comm check. How do you read? We're having serious problems. We're tumbling end over here. We're disengaged from the Agena. What seems to be the problem? We're rolling up and we can't turn anything off. Continuously increasing in left roll. Whew. Okay, let's see here. Okay. All right. Okay. Oh. Shit. All right. Holy smokes. Trying to correct the rates. Yeah, you think. Close the RCS. Okay. Okay, move us back to one ring. Yeah, we've regained control. Oh, excellent recover. Bring the spacecraft home as soon as possible. Okay, let's plan entry with the splashdown in the Atlantic. Yeah, problem is we're not anywhere near it. The Atlantic. I'll see what I can do. I'll see what I can do. If we go for about right here. No, let's be safe about this. That should splash us down approximately in this zone. We could. No, we can't retro at apogee. That's not going to happen. Right there. Okay. Retro at orbital. Cursor. Okay. Well, that was certainly something else. What's our time down to retro? 26 minutes. Okay. Oh, that's going to be a problem. Let's start going. TR256 circuit breaker close. Okay. Left O2 bottle open. And close these two circuit breakers. Reentry C-band beacon. Real time and acquire. Are batteries holding up? Okay, batteries are holding. Right. Okay. Okay. And that was crazy. And unfortunately, we exploded our docking collar off. That was a little insane there. Okay. Command reentry. There we go. Yeah, holy smokes. I completely forgot that that was a thing that happened. Scared the ever-living crap out of me. Four, three, two, one, mark. That's good. Okay. Radar off. Five minutes from retro burn. No, we're not. Proceed with the 256. Yep. Going through the checklist now. And we don't need to check this complete. Okay. 256, we're go. Amber reentry. Main batteries are on. Verified battery volts. Prop gauge, RCSA. Record continuous. Cryo quantity off. Antenna select reentry. Platform attitude. High. Rate command reentry. Gyros primary. Ohms system shut down. Okay. A and B on Acme. Indicate retro attitude. RCS push. I've already done that, but we'll do it again anyways. Retro power arms. Hold 20 degrees pitch down. Platform attitude rate high. High frequency transmitter is already off. Primary pumps off. Secondary pumps off. Radiator in bypass. Close up cabin recirc. Okay, 1 minute to retro checklist. Five, 4, 3, 2, 1, 0. Ohms line separated. Electrical separated. Staging. Staging confirmed. Okay, T minus 30 minutes. Or 30 minutes, 30 seconds. Auto start. Of course. $13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Okay. Staging. Getting ready for atmospheric entry. Verify D-ring. Preparing for entry. Roger, good luck. Okay, safe. Computer attitude low. Computer attitude low. B is off. Boost insertion, retro sequence. Cryo H2O2 heaters. Ohms control propellant. Fuel cell. Tape recorder. Fuel cell shutdown configuration. And landing squib arm. Okay, we are prepared. Starting entry checklist. At TR plus 1430. Stabilization control attitude 0 degrees yaw. 170 roll. Horizon at top of window. Okay. All right. We're in reentry attitude. And that was an insane mission. We had a little Gemini 8 going on there. A little Gemini 8. Oh, if you guys would like to see it, let me... There you go. You have DVR enabled. I don't know if you can roll back or not. But once we're done, it'll be uploaded. That was some top tier stress. I'm not even gonna lie to you. Okay, you've crossed entry interface. Prepare for landing. Roger. Okay, prepare for landing. Do that and that. Let's get the mood comfortable here in the cockpit. Ah, all those preparations I took and where it looks like we might be landing on land today. How rather unfortunate. We're gonna need to get our glide fixed. Let's get our glide fixed. We need to increase our glide. Increase the glide as much as possible by going lift vector up. We may be able to steer to the right a little bit. Let's do that. Let's steer to the right. Let's go to the right. Let's see how this goes. Yeah, it looks like we're gonna land long. Okay, alright. It would really suck if I had to do this mission over again. Because it told me to put the cursor on the west coast, and that's exactly what I did. Come on. Come on! Oh! Stretch it out. Yes, how very unfortunate this is. Waiting for the drogue. Yes, we've already got the drogue out. And everything looks good. I may, because I really am not in the mood to do this again because of some shitty inclination. I said put it on the West Coast, and that is exactly what I did. Yeah, we landed in Africa because of shitty Aegina inclination, unfortunately. But it's fine. I can bypass mission requirements. It's fine. Man, how unfortunate. That sucks. Yeah, we still did it. Nice. Okay. Splashdown was not a goal. It was actually just return home. Nicely done. Max G's 9.8. That's pretty good. Welcome home. First docking in history. Unfortunately, it didn't go as planned, but at least it's a docking with a safe landing. We are all okay. That is correct. I'll guess you will complete the job. You bet. Half the tire scores, it will be 7-7 if all goes well. I also heard that if successful, it will be the last Gemini mission before Apollo. Yes, and this was my last Gemini flight. It is sure a great craft and a huge achievement. Indeed it is. Can't wait for my next flight, but can't wait to test that Apollo command module. Unfortunately, with all the issues surrounding it, but it sure is a beautiful craft. I'm sure they will sort out the issues before flight, and there's unmanned test plan. Indeed. I'll see you at the debrief transmission end. And look at that. With that, we begin. A flight in the Apollo. The moon has never felt closer. The Gemini program has successfully created the technological bridge needed to make the journey to the moon. With the biggest rocket ever built by man, carrying a spacecraft with components of the most advanced technology ever flown, a crew of 3 astronauts will attempt the journey to the moon. To get there, a lot of things still need to go right. The Apollo command module is yet to be tested for manned flight, and the lunar module needed to actually land on the moon is long overdue. The rocket used to carry the Apollo spacecraft into orbit and towards the moon is the Saturn V, consisting of 3 main stages, S1C, S2, and S4B. The first stage, S1C, consists of 5 F1 engines used to carry the entire stack through the atmosphere. The combined forces of the 5 F1 engines are 7,500,000 pounds of force. The center engine is fixed, while the 4 outer engines can be gimbaled for attitude control. And by the way, the amount of foot candles of light that this rocket produces is equivocal to the sunrise. The second stage, S2, is powered by 5 J2 engines with a total thrust of 1,000,000 pounds of force. It will accelerate the stack through the upper atmosphere. The third stage, S4B, is powered by 1 J2 engine with a thrust of 200,000 pounds of force. The engine will be fired twice, once during ascent and once to bring the spacecraft onto a lunar trajectory. a procedure referred to as translunar injection. It will also carry the lunar module and the spacecraft adapter itself. The auxiliary propulsion system is used as the primary attitude control until the S-4B is separated after TLI. A new spacecraft, the Command and Service Module, has been developed. It consists of two major parts, the Command Module and the Service Module. The Apollo Saturn V launch vehicle will carry the spacecraft into orbit around the Earth onto a lunar trajectory. The spacecraft will separate from the launch vehicle and continue the journey around the Moon back towards the Earth just before reentry. The Service Module will be separated and the Command Module will enter and splash down in the ocean. During the ascent through the atmosphere, the launch escape system is used to carry the command module and its crew away from the launch vehicle if an emergency will occur. The command module houses a crew of 3 in a pressurized compartment with equipment bays, controls, displays, and systems needed for the entire journey. It has its own electrical system as well as a reaction control system needed during the atmospheric entry. It also has a forward hatch that will be used to ingress and egress the lunar module once it's complete. The service module is an unpressurized part of the spacecraft carrying mandatory equipment needed for the long duration of a lunar mission. It carries the primary electrical system, reactants, the service propulsion system, and all its components. The SPS is the main engine of the spacecraft and is used for all major burns. The SM also carries the main reaction control system for attitude control and translation control. The launch escape tower is back. It was decided to depreciate. It's actually deprecate the ejection seat method used in Project Gemini and return to a similar escape methods used in Project Mercury. During the launch and ascent of the Saturn V rocket, the launch escape tower can be used to separate the command module from the failing rocket with an intermediate descent and splashdown. A Saturn V launch has 5 abort modes, where the 3 first modes will use the launch escape system. After staging from the S1C, the launch escape system is jettisoned as it is no longer needed. The controls and displays used to control the spacecraft is located in the command module. It consists of hundreds of fuses, switches, and controls used to configure and operate the spacecraft. I actually counted every single switch in the cockpit. There is 1.6 thousand interactable things in the cockpit. In NASP, I'm not sure about Reentry. Reentry might have a few less, but the spacecraft itself, because NASP is the truest simulator, 1.6 thousand. A state-of-the-art general-purpose computer named the Apollo Guidance Computer is used as the primary guidance method, using optics as its eyes, an inertial measurement unit as its legs, and the Apollo Guidance Computer can navigate and maneuver the spacecraft from launch to entry with input from the crew and mission control. Actually, the Apollo Guidance Computer does not navigate the spacecraft through the launch. That is a popular misconception. It's actually the LVDC launch vehicle digital computer on the instrument unit. Yes, after being an astronaut for a long time with experience flying both Mercury and the Gemini spacecraft, with the skills and mind needed to get out of the most severe emergencies, the press expect to see you in a seat for the Apollo program. Martin, the director of flight crew operations, has made you a commander of the second Apollo mission with the purpose of testing the spacecraft in Earth orbit as well as the lunar module. As in Project Gemini, veteran astronaut Aaron will be part of your crew and will be the command module pilot. Lotkins has been training for his first trip to space and will join you as the lunar module pilot. Oh, might I add that the second Apollo mission would have actually been very similar to Gemini. They launched the LEM separately from the command module. The command module will then perform its active rendezvous and docking with the LEM for testing emergency purposes. Then everything in Apollo 9 happens. So it's a really cool mission, and I do have the program on NASP, and I may be streaming it at some point after my vacation's over. A lot of pressure is upon us if we are to succeed in landing on the moon in this decade. It is therefore, vital that each and every Apollo mission leading to the lunar landing is a success. You are scheduled for the Apollo Command Module Academy to begin training immediately. Before attempting this campaign, you should get the command module. Yada, 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 yada. Other astronauts who have gone through the academy can also be found in the official Reentry Discord group. Yada, yada. Okay. Commander Patrick is strapped in and ready for his crew, currently performing a test in preparation for the first manned Apollo flight. Patrick and his crew have been performing a full dress rehearsal all day. The brand new Apollo spacecraft seems to have some issues, and the team is working hard on figuring it out. As backup crew, you and your team will be joining the Launch Control Center to oversee the rehearsal. And I will shut up now. Campaign 3, The Dark Side of the Moon. A lot was learned from the tragic loss of the first Apollo mission and its crew. The new and improved Block 2 command module is now part of the Apollo spacecraft and is ready at the pad. You are part of the backup crew for the flight and will prepare the cockpit for prime crew ingress. The Apollo Command and Service module consists of hundreds of systems all working together to bring a crew of 3 to the moon and back safely. To become a great command module commander, it's important to know the layout of the cockpit and to easily find the switch and system you are looking for when needed. These procedures teaches exactly that. Take your time. For each checklist, we will use the run feature to proceed the mission. Use the mission pad checklist as a reference. MCC will guide you through. And this is going to take us a long fucking time. Yeah. a long time. Right off the gate, we get one of the simultaneously worst and best missions in Reentry. This is sort of a rite of passage for everyone that ever flies Apollo. If you don't do a cold and dark startup of this command module, you cannot call yourself a command module pilot. It is indeed a rite of passage that everyone has to go to. It's an initiation, a suffering. It's 100 times more switches and complications than Gemini's cold and dark startup, and a million more than Mercury. Okay, everything's loading in while we're waiting on that. Okay. Good morning, Sunny. We are 3 hours and 10 minutes from launch. Prime crew is scheduled to ingress in about 1 hour. We have 14 checklists to complete. 13 will be done by you. There's a lot of switches to flip and systems to verify. It is a good task for learning the panel layout and where switches are. Roger, let's get this craft set up and ready for Prime crew ingress. Roger, open the hatch. And here we go. Where is it? Must be down here. Yes, there we go. Roger, hatch is open. You should also remove the seats to increase your working space. Yes. For each checklist, you will notice that the spacecraft is slowly coming to life. For this mission, the Prime crew will take it into Earth orbit, perform tests, and return. Anyways, let's get started. We don't have much time. You should be familiar with the cockpit from the Academy, so start by executing the backup crew ingress checklist. Okay. Ah, nice. They got these in here now. That's good. These integral lights here should not be able to be on right now, but that's a-okay. We'll let that one slide. I'm going to preemptively set the integral lights all the way to maximum so that when we do get to this procedure, it will look fackin' amazing. Okay. Let's go to checklists and backup crew ingress. And yeah, there is so much to do. I know where everything is, but I really don't want to do this one by one without a system that keeps track. So I wonder if there is, it's probably not in here. That's okay. CS, yep. Once we get all these in the primary switch positions, it's not that bad. Post-landing vent valve. Yep. Let's go. Probe extend, release off. Talkbacks gray. Off. Close. Good. Propellant quantity. Close, 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 close. Off, 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 off. Close, 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 close. Good. Command off. Service module. Off, off. Open, 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 open. Okay. Okay. Electrical power. Yep. Yeah, this is not supposed to be a spring-loaded switch, I don't think. 0, 180. Normal. Heaters, on. 2, increase. So, and on. This part is actually not done until way later. But I suppose we'll let it slide. And actually, this is supposed to be cross-tied onto both of these buses, like so. You should always reset the sensing circuitry after tying AC electronics. You're supposed to be on right now. You got the fuel cells tied. Whatever. These two are supposed to be open for this mission as well. This is supposed to be over here. Actually, no, that's right. I was thinking of this one. Okay. Okay. Dum. Open. Yep. Okay. PLVC. Glycol accumulator. Suit circuit return. And auto control valves. All right. Continue with the activation checklist. About dang time. Okay, activation checklist. Here's where I don't need the runnables anymore. Caution and warnings on. Caution and warning, power is up. Or at least it should be. Why do I have no... I have no power up here. Cells. Hello. Well, there's supposed to be ground support equipment, but... the fuel cells are putting out amps, but no volts. That's natural. Yeah. Well, that's not supposed to be happening. Computer circuit breakers close. We'll just proceed with it. Now 65. Verify clock is ticking forward. Good. FDI GPI power to 1. And verb 37. Enter 01. Enter. Yeah, it's like they had us go to internal power, which is not right. Let's just keep an eye on the batteries and hope that they don't drain. Yeah, those are low. Definitely something wrong with the scenario here. We're not supposed to be on batteries. Checklist complete. Backup crew section of the checklist, starting from the top and following them in order. Caution warning status check. Caution and warning, normal, then CSM. Power 2. Supposed to be a master alarm for that in real life. Power 1. Again, master alarm in real life. Test 1. Good. 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 To boost. Good. 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 Back to normal. Good. Lap test 2. Good. Good. This one should be on, but that's okay. Release and acknowledge should turn all these lights off, but the master alarm should stay on if it does come on. But the lights will not show up. That's what it should be doing. EMS pre-launch. We already have those EMS circuit breakers put in. And we can verify that. Yep. See. This is a problem. What this is supposed to do, the ground test accelerometer is supposed to remove the acceleration from gravity. When you go normal, this is supposed to remain on 0. If it ever changes by more than 0.5 per second, you've got yourself a serious problem. So the ground test accelerometer logic is not done correctly here. Delta V set is something you're supposed to be able to do without the normal switch being on. But that is fairly trivial. One 1586.8 Delta V test. That's exceptionally good. Normally you'd see about 19.7, 19.8. Sometimes up to 20. Should stand by. Test 1. Then normal. Good, that works properly. Slew. Okay. Test 2, and after 10 seconds, we should see 0.05 G. Good. Test 3, and set to 58. That's annoying. 58, there we go. All right. Lift vector down light is on, good. Test 4, scribe tracing pattern. In real life, you'd see it go down, but way below this line. It's not actually supposed to trace on this line, but it is definitely good enough for gamified Apollo. Trace to the top. No, this should trace up to the top to about here. I don't see it though. Lift vector uplight, that's good. And then range set. There it is. I see it. Standby and off. GTA down. glycol loops. So secondary to normal. And secondary. AC1. Good. Although not that fast. This is a pump after all. It would explode if you did that. But gamified. It's good. Good. Then off. And this spin down would be really slow in real life. Would take like 30 minutes for that to actually reach 0. Primary loop activation. Right now, the primary loop would be on GSE, ground support equipment, so it should be holding pressure. But as soon as you do that, bam, pressure would, well, it would stay the same, but it would flip to internal glycol pumps. And that's good. Now we go radiator flow control power, then take it to 2. Good. Auto, power off. Good. Direct O2 will adjust to 0.4 plus or minus 0.1. So let's take it down to just past halfway. Oh, 0.3. Let's get it just a tinge more. And this direct O2 valve is actually simulated remarkably well. I'm very proud of that one for Petrie. This is something that NASP is struggling with, is the diameter of these pipes. That is simulated remarkably well. But the little things else that are really easy to fix, I might make a list of. Just because they're really easy to fix. It wouldn't require any major systems remodeling. It's stuff like this. We're on the acknowledge, but these lights are still on. We flip power, but the master alarm doesn't come on. So it's really small things, insignificant things like that. And, well, most importantly, this is actually a huge problem. Ground test accelerometer is supposed to subtract the force of gravity. But it's still there, so. Standby inverter 3 checkout. Yep. So this is going bam, 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 bam. Good volts. That is normal. Bam, 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 bam. Good volts. And off. There we go. That's it. Fuel cell and radiator flow. Check fuel cell radiators. They're all going to be normal. So, and open. Good. Float bag check. This is off, close, vent, open. Lower hand equipment bay, ECS valves. Secondary is bypass, primary accumulator fill valve. Off, yep. Primary accumulator valve open. 378. Primary accumulator valve is open. YY strip retract. Yep. 382. Suit heat exchange primary glycol flow is on flow. Good. Suit flow relief. Suit flow relief. Where was that again? I forbore. Ah, yes. I was literally just reading that. Off. Suit heat exchange, secondary glycol flow. Good. Primary glycol flow minimum. Good. Evap water control. Auto. Good. Remote. Good. Close coolant attenuation panel. CO2 constraint attenuation panel. Or CO2 canister, that is not constraint. Yep. Diverter valves are center. Close CO2. Yep. Diverter valves are center. Main regulators are open. And H2O glycol selector, both good. Cabin repress, both. And off, good. Waste tank servicing, closed. Potable inlet tank, close. Waste tank inlet auto, good. Pressure relief on 2, good. Forward pressure relief valve closed. The LMCM delta pressure should actually show 0 because they're both at sea level, and the LEMS pressure relief valves are open, but it's, you know, they're not docked, so the logic's probably not engaged. It's not a big deal. The NASP does the same thing. 3 full flows, cold, max cool. Good. And drinking H2O supply valve off. Good. Right hand equipment bay. All closed except high gain antenna 2 open. Yep. 226. Fuel cell radiators reacts. And U. Good. 229 is the main release in the vacuum oxygen ignition pumps. Open. Good. Skip. 250, all closed except the 2 yellows and the 2 bat C's to main bus. Overboard drain valve off. Waste stowage is going to vent, and the battery is going to close. Yes, there we go. Repress O2 closed. Good. Next up is lower equipment bay. Utility power off. Floodlights 1. Fixed off. Optics off. Heater. Numerics as desired. Floodlights will keep off. As a matter of fact, the floodlights up here are mighty bright. That's better. That's way better. Look at that. That looks really good. Okay, mission timer. It's gonna go reset, then start. Vent timer, stop, stop, then reset. Good. And 1.1 to 1.9. Hello, there's supposed to be test 5. 4A, 5B. Rendezvous radar test is on operate. Good. This is supposed to be a spring-loaded switch. Command module RCS heaters off. These to heater A. Optics 0 on. Good. Slave to sextant. Direct. Low manual. Condition lamps on. Telemetry accept. Reticle brightness as required. Science utility 163. That's off. And 163. That's off. 164. Where is it? I don't think 164 is in here. It's supposed to be... supposed to be down here. Ah, right here. No. Okay, well, 164 is nowhere to be found. That's quite all right, though. I'll find it later. Cryo AC power. Panel 181. There's panel 181 down here. Here's 180. 181 should be down here. Ah, yes, 164 and 181 are in research. Okay, alles klar. Ordeal switch position check. Already know this one. Inertial off. Hold that. And this is actually... I like this to be simulated, but I'll talk about that later. Left hand couch checks. Surge tank relief valve open. 375. That's... Here we go. Yep. PLVC's normal. Demand regulator is both. 380. 380. Demand regulator. Yes, both. Good. Suit test off. Suit return closed. Primary glycol to radiators. Normal. Boost enter. We are in glycol reservoir. O2 supplies are open. Repress package on. Coas off. Utility power off. Post-landing beacon off. Post-landing vent off. Dial marker off. Panel 8, all auto RCS switches off. Floodlights 1, fixed off. Numerics as desired. That's as desired. Lights, secondary control system, good. Panel 8, CMRCS heaters open. Float bags open. Logic open. Arm open. Everything else closed, good. Emergency detection system power off. TVC servos off. FDI, GPI power select both. SCS electronics, GDC, ECA. Signal conditioning power. And BMAGs. Nope, BMAGs on warm up, sir. Yep. CMC, attitude, IMU. Yep. 5-1. 1/2. CMC, GDC. Rate, accelerate. Not rate high. Trans control power. SCS free. BMAGs rate 2. Thrust, norm. Yeah. SPS gimbal trim should be 0. $162.90. Good. CSTVCs on rate command. Gimbal motors off. Center of gravity to LMCSM. Entry landing system off. Cage manual. Logic off. Dump off. These are supposed to be guarded switches here. IMU cage. EMS roll off. Off. Angle of attack. 0. Yep. Gimbal position indicator. And gimbal drivers are in auto. Event timer. Stop, then reset. Suit to cabin. This is supposed to be off. Accept. Command module. RCS pressure is off. Good. Good. Okay. Oh, forgot to close these. Yeah. You can't fool me. Rate, Excel, rate. Can't fool me on that either. Those are indeed supposed to be 0. Link telemetry. No, 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 no. You can't fool me. Accept block. No, 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 no. Can't fool me. All right. We gotta hold on. Clear. Clear. Yep. Entry monitoring system. Yes, we did that too. We did this one too. Yeah, we did a lot of checklists that I forgot to actually have the mission register that I did. Right hand couch check. Here we go. Decking target off, utility off, coas off. Yeah. Good. Flight signing bus. So batteries. Open. Open. Good. Operating system compressor. Open. Good. AC1, AC2, AC2. Our fuel cells putting out. No. Because we're not on internal power, but despite not being on internal power, we still get problems like that. Which is a big problem, as we are draining our batteries rather rapidly here. Anyways, non-essential bus off. Waste dump, good. These are supposed to be open because they're not powering anything. But, And gauging, AC1, telecom groups alternating, glycol pumps, seat compressors, both off. Good. Radiators, all center, fuel cell radiator talkbacks, gray. Purges off, heaters all on. Fuel cell reacts, good. 1 and 3 are supposed to be off. Yes. 1 and 3. Yes, I know they're supposed to be off right now. Fuel cell 2 and fuel cells 1 and 3 off to center. And fuel cell main A 1 and 3 talkback barber pulls 2. And main B talkbacks all off and barber pull. Main B reset center. And then these good. This one's supposed to have just a little bit of flow, but that's all right. Battery charger off. Just putting out nothing. Good. Good. Well, these are really low. These are really low, my bad. Yes, and that's what we like to see, except that's more of pyro. This is supposed to be on 37. Pyros go to that. And it's exactly flipped around. Okay, that's great. Ignore that. And dual stat inverter check. We already know that's good. Yeah. Propellant is good. Helium is good. Nitrogen is good. Nitrogen is good. Temperature is good. Auto. Good. Max, increase, primary, normal. VHF, SM left, good. Transponder off, power amplifier off. And voice, good. PCM, ranging. Center, data, command, reset, then off. Power amplifier, talkback is barber pull. Omni Bravo, squelching noise, +1 on both. VHF AMs are off. Receiver on off. And beacon off, ranging off, squelch switch to enable. That's not in there. Fuel cell react valves, norm. Purge line off. Tape recorder, good. Recorder, good. And rewind, verify tape motion, then off. Oh, hello, tape motion. You're not working properly. You're supposed to be barber pull right now. Both of these have to be on in order for this to actually show great, but that's quite all right. And PCM bitrate, pulse code modulator bitrate high. Signal conditioning equipment normal. Pre-modulated processor normal. Mission timer, reset, then start. Good. Acknowledge, CSM, power 1, lamp test center, post-landing vent valve locked. Cryo pressures, tank 2. Right. The logic bus is probably unpowered. No. Okay, I guess we just don't have tanks. Cool. Yeah, we'll get to that later. And that's good at least. And we could take everything to auto. And good. And 20 seconds. Reset for 58. Good. Secondary coolant evap. Yep, secondary coolant pump off. Glycol in temp manual. Steam pressure manual increase for 58 seconds. And then decrease for 1, 2, 3, 4, 5, 6, 7, 8.5. There we go. H2O flow off. This is actually supposed to be labeled manual and appear like that. But that's quite all right. Cabin temp manual. And thumb wheel max decrease. High gain antenna power off. Auto wide. Good. Good. Yes, I know we can't turn those off because we're currently reliant on them. Yes. There's something wrong with the GSE. Ooh. Hello? Okay. Fucking shit. Really? Yeah, well, apparently, battery B manages to not be tied to anything somehow. There's very strange things going on today. But hey, we'll save it. If battery B is fine, then we will save it. Yes, clear. Okay. Beautiful craft, isn't it? Yeah, sure, if you want. Looking forward to flying it. Hallelujah. Communications checks. Blah, blah. That's supposed to actually be gray after 90 seconds, but I am not complaining in that regard. Duplex. Spin and okay. And oh. Okay, that's fine. That's fine. Makes my job easier. Okay. Okay, panel 9, VHF ranging goes to normal. No, my bad. This one goes to normal. This. And then uplink telemetry goes to uplink voice backup, then to data, then S-band goes to down voice backup, and then center. Completion of comms checks. Right, let's forget that the panel is not added for whatever strange reason. Okay. Panel 10 is not in. Caution warning off. And pull them circuit breakers. Okay, comms check. Complete. Verify couch configuration. Couches are ready. Okay, prime crew pre-ingress procedures. All right, I guess we don't have to do that one. Awesome. We're done here. Spacecraft is powered up. Next time, we're going to lift off and go to the moon. Thanks for stopping by.